Good morning to all. In the chemical reaction engineering subject, unit is that fluid solid particle reactions. Okay, so solid catalyzed reactions. So which types of catalytic reactors are available for the entire process? Okay, so catalytic reactors are available in the form of fixed bed and fluidized bed. There is a number of two, okay, which are used in the commercial scale. So let's start a catalytic reactor. Solid catalyzed gas phase reactions are of great industrial importance. Solid catalyze that means કે જે પ્રોસેસની અંદર catalyst solid હોય. Okay, so catalyst is a solid catalyst and gas phase reactions, અને reactions gas phase માં હોય. So most of the common use of the catalyst is the solid catalyst. So these reactions are effect on commercial scale in fixed bed and fluidized bed. So let's see fixed bed reactor कौन से है और fluidized bed reactor क्या है. A fixed bed reactor also referred as a packed bed reactor. Fixed bed ने कहेવામાં આવે છે packed bed reactor. Okay, both of name is the fixed bed is that fixed bed, either it will be said as the packed bed reactor. Okay, it consists of a cylinder of a large diameter with multiple catalyst bed. It consists of a cylindrical shape of a large diameter, then it having a multiple catalyst bed, layer 1 2 3, either 1 2 3. So numbers of catalyst bed or many tubes in parallel pack bed with catalyst and encased in a large cell. અથવા તો ઘણી બધી ટ્યુબ્સને પેરેલલ પેકમાં કનેક્ટ કરીને વિથ કેટલિસ્ટની સાથે પેક કરીને પેરેલલમાં જોડવામાં આવે છે, પણ ક્યાં? એ પણ લાર્જ સેલના ડાયામીટરની અંદર. In this reactor, reactant gas flow continuously through a stationary bed of a catalyst. In this reactor, reactant gas flow continuously through a stationary bed of catalyst. These reactions makes us relatively large size catalyst particle for a low pressure drop. This reactor used for the large size catalyst particles for the low pressure drop, and the catalyst particle may be granular, pellets, cylindrical or spherical. Okay, doesn't matter which types of matter is that which types of you can use it. Okay, so here is the given numbers of types of reactors. Okay, so it is in the form of, first we say that a multitubular construction is required when large quantities of heat must be transferred to the surrounding, as in the case of high exothermic reactions. Okay, referring 6.13b. For why? For the purpose of that multitubular, કે જ્યાં એક કરતાં વધારે ટ્યુબનો ઉપયોગ શા માટે કરવામાં આવે છે? To the it requires a large quantity of heat, large quantity of heat must be transferred to the surrounding system, to the surrounding, in case of high exothermic reactions. Okay, the reactions is highly exothermic reactions. Refers 6.13b. So it is a one of type of that. First one is a fixed bed uh, reactor. Then B is the multi-tube fixed bed reactor, in which a tube of catalyst, multiple catalyst is achieving there. So as per first of all, we see the figure number 1. રિએક્ટરની અંદર એક બેડ હોય છે. So the bed is consistence of catalyst, okay, so which is packed bed, and coolant is generally uh, entering at the lower portion of the vessel and out from the top portion of the vessel. Then reactant gas is a flow through the bottom of the vessel to the top of the vessel. Okay, so it's flow from the bottom to top. And the multi-tube fixed based reactor, in which the tube which is consistence of a catalyst, and there are number of bed which is connected in the series. Okay, so fluid must be pass all of this catalyst. Okay, so coolant in at one coolant is in inlet from the side where the catalyst bed are fixed it. Okay, so at the bottom coolant is in. For the coolant we are using as a cold steam, as a cold water. Okay, anything we can for the process we use. And the product reactant gas is the inletting from the bottom portion of the vessel, and it will be the in the form of the product gas. Okay, reaction take place where exactly the catalyst is the play role. Okay, and the third one, which is another different type, which is a multi-bed reactor. It is a multi-bed reactor. Okay, so first of all, at a lower portion the reactant gassing, as well as per we discuss. Then सबसे पहले क्या होता है, नीचे सबसे लास्ट वाला पोर्शन है, उसमें से क्या हम करते हैं, गैस को इनलेट करते हैं, और टॉप पोर्शन में से हमें प्रोडक्ट गैस मिलता है. बट इन बिटवीन दैम there is a lots of number of processes done. So it will be in the form of this. So these are the first. At the bottom portion, the bed is first stage with a small amount of catalyst. First stage के अंदर the catalyst amount it should be low. Okay, first relatively it's low, so bed size is very small. Then after it providing a cooling system, okay, now coolant, and with a small amount of catalyst. Again, the fluid is send it to the next bed. Next bed is much greater than the first stage, and then again apply the coolant. Then again it is send it to the next catalyst bed. Then again it will be the increase the more the size of catalyst bed. Okay, so now at the final age, the pack bed fourth stage, the within the large amount of the catalyst. Okay, then again it is supplying the cooling, and at the last we got the product gas. An alternate arrangement, let's do the alternate arrangement that reduce temperature variation in the fixed bed reactor consist it consists multiple catalyst bed with a cooling coil and placed between the stages. Okay, so in this arrangement, conversion of the first stage where the reaction is fast and it is kept low by using less amount of catalyst. કે જ્યારે રિએક્શન શું હોય છે ખૂબ જ ફાસ્ટ, ત્યારે જે કેટલિસ્ટ યુઝ છે એ કેવો હોય છે ઓછો, એઝ કમ્પેર ટુ ધ અધર સક્સીડિંગ સ્ટેજીસ. જે આગળ વધતા જતા જેટલા પણ સ્ટેજ હોય છે એની કમ્પેરિઝનમાં આ જે કેટલિસ્ટ અમાઉન્ટ છે એ ખૂબ જ એટલે ખૂબ જ ઓછી રાખવામાં આવે છે. So this one is figure 6.13c. Okay, so these are the fixed bed reactor. So bed are fixed at the reactions in the reactor. Okay, or the next one is that a fluidized bed. So fluidized bed reactor, let's see. Fluidized bed reactor, this reactor are especially suitable when frequently catalyst generation is required for or for the reactions with a very high heat effect. કે જ્યારે આ પ્રકારના જે કેટલિસ્ટ છે જનરલી યુઝડ ફોર વેર it is required for the regeneration of catalyst and also used for a reaction with high heat effect, કે જ્યાં હીટ ઇફેક્ટ ખૂબ જ વધારે હોય છે. ઓકે, then a fluidized bed reactor consists of vertical cylindrical vessel, large diameter containing a fine catalyst particle. Then a reactor gas is introduced to the bottom of the reactor at a rate such as the catalyst particles are suspended in the gas stream without being carried out. Under this condition, the entire bed of the catalyst particle behave like a boiling liquid, and this action tends to make the compositions of reactor mixture and the temperature uniform through the bed. Okay, so 6.14a shows that fluidized bed reactor for a stable catalyst which does not require regeneration continuously, which does not require regenerate continuously. Figure 6.14a shows the fluidized bed reactor for a stable catalyst which does not require regeneration continuously. So let's see 6.14a at the fluidized bed, કે જ્યાં નીચેથી રિએક્ટન્ટ ગેસ છે એ શું કરવામાં આવે છે પાસ કરવામાં આવે છે and the catalyst in the form of fluidization conditions. So where the fluidized condition, the reactant gas is similarly flows from the bottom portion of the vessels, and then it is removed from the top of the vessels. Fluidization bed ની અંદર શું થતું હોય છે એક્ઝેક્ટલી જે ગેસ ફ્લો રેટ છે ગેસ ફ્લો એ પાસ થાય છે and at the fluidized bed where it is supplying the coolant. Okay, so this figures or this fluidized bed reactor which is not require regeneration continuously. Okay, catalyst, regenerated catalyst is not required continuously. Okay, this one is a batch operation type, so this one is not required. If once times a process is done, then after we using the other method, then using this method, so we can control, we can regenerate it.